Hello everyone, we are Group D and today we are going to present our KNP 4073 Advanced Manufacturing System Group Project, which is Automated Cake Manufacturing Plant for Company Z. So let's begin the presentation. So these are our team members, which includes me, ARIEL HAMMESLY CHIENG 82438 as the plant manager, Kenny NERU 82631 as the facility engineer, DARRELL David 82512 as the quality control engineer, and finally Niden 82643 as the production engineer. Let's begin with the background, shall we? So, Company Z is a small-scale cake producer with a 20-year history of serving local supermarkets. Historically, they've relied on manual and semi-automated handmade production lines. However, the company recently secured a major contract to export to the Middle East. This is a strategic catalyst. To fulfill this volume, Company Z must move toward a high-capacity, fully automated system to maintain the quality standards required for global markets. So what are the problems and challenges that are going to be faced by Company Z to upgrade to a fully automated firm? The first one is capacity gap. Small manufacturing firms often struggle to meet high volume export demands using manual labor. Next is technical and workforce barriers, where existing management lacks the technical expertise for automated systems and the current workforce is not trained for high-tech environments. Next is risk factors. Transitioning requires significant capital expenditure, which is CAPEX, and carries the risk of black box automation, where operators don't understand the complex systems and the internal of the system they are managing. The objectives for this project is first, layout and system design, which is to propose a comprehensive new layout that would encompass a completely automated manufacturing system, especially focusing on the application of group technology and cellular manufacturing. Next is process monitoring and integration in order to find the most appropriate manufacturing execution system, or in short, MES, for real-time process monitoring and to find the best way of maintaining consistent cake quality through real-time monitoring. Next is system configuration analysis, which is to identify the automation model that would facilitate the company's entry into Middle East market by making a comparison between the centralized and the decentralized model options. Next is quality assurance and inspection. The need for a development of a study structure of quality control comprises detailed explanation of advanced inspection and techniques like automated vision systems and comprehensive quality assurance. And finally is financial rationale, where providing a detailed economic justification for the new production system with break-even points and capital expenditure analysis that ensures the cake will be financially stable. In our literature review, we first examined a study by Zafarzadeh and Jackson. The methods and findings from this research is using a qualitative case study in the automotive industry. They identify 18 hindrances to automation, specifically the danger of black box system that operators don't understand. Next is our adaptation for Company Z. To prevent these issues, we are adopting user-friendly interfaces or HMIs and balancing technology with lean principles to optimize flow without creating hidden defects or unnecessary complexity. Our second study is Semi-Auto Cupcake Master, boosting baking efficiency and quality. This study inspects traditional baking methods and design a system incorporating automated dispensing and program chain conveyors. They found that automation in physical flow is essential for constant cake volume and color. So what do we adapt from this is we are implementing their systematic approach to control product flow during the critical baking and cooling phases, specifically utilizing automated mixing and decorative tools to ensure structural integrity and aesthetic consistency. And finally, our third research, which is the opportunities and challenges for implementing automation among selected SMEs of food manufacturing industry. Through semi-structured interviews with small firms, researchers confirmed that while automation boosts competitiveness, costing and personnel training remain the biggest barriers. So, what do we implement to address this issue? We have developed a strategic plan that includes dedicated staff training for complex apparatus and a modular design that allows the company to remain flexible even with high investment costs.
Next, let's move to the brain of the factory, the control architecture. We analyzed two main approaches. Option A was a centralized system. It's a one giant server running everything. We do not select this because it creates a single point of failure. If that server goes down, the entire plant stops. It also requires expensive and heavy cabling. Instead, we select option B, a distributed or decentralized control system or DCS. In this setup, every machine cell, mixing, baking, packing has its own local brand or PLC. Why is this better? There are three reasons. First one is the speed. Critical decision like adjusting oven temperature happen locally at the edge in milliseconds without waiting for a central server. Second is reliability. It offers fault tolerance. If the packaging line has an issue, the mixing and baking lines don't just crash. They can continue running and send product to a buffer zone. The third one is scalability. When company Z is ready to add a second line for export, we can simply plug and play new nodes without rewriting the entire plan's code. Moving on to the physical process. We are producing sponge cake family production line. As you can see on the timeline, this is a continuous five-step flow from preparation to packaging. To support this, we have selected three key technologies. First, pneumatic conveying. For flour and sugar, we move away from open belts to fully enclosed stainless steel piping. This creates a closed-loop system that eliminates dust explosion risk and contamination. Second, the tunnel oven. We chose a direct gas-fired oven, DGF. This gives us precise control over the baking profile using infrared sensors, ensuring every cake has the exact same texture. Finally, the logistic. We are replacing manual forklift with laser-guided AGVs. This increases safety by separating human from heavy load and allow us to change route via software as the warehouse layout evolves. Okay. Next one is the plan design and infrastructure. From the given figure, it's our proposed layout for the cake manufacturing. Now let's look at where all this equipment live. This is our proposed plan layout. We have adopted U-shaped configuration. This is strategic because it locates our shipping and receiving docks on the same wall. It drastically reduces yard traffic and allows security to focus on a single entry point. Crucially, we've designed this layout around hygiene zone to meet HACCP standards for export. The high K zone. This include mixing and baking. We maintain this area at positive air pressure, higher than 20 Pascal. This means air always flows out of the clean room, preventing dust or pathogens from entering. The low K zone, warehousing and packing, are physically separated by rapid roll doors. Underpinning all of this is our infrastructure, a redundant fiber optic network for data integrity and N plus one UPS power backup to ensure we never lose control of the system, even during a blackout.
First is our manufacturing monitoring system. Our group implement an advanced monitoring system. We follow a clear four-step workflow: presentation, examination, decision, and action. First, every cake is positioned so our sensor can see it perfectly. We test it for surface crack, size, and weight. Then the computer makes an instant decision. Is it good or bad? If it passes, it goes to packaging. If it fails, it is automatically sidetracked for rework or disposal. So to make this system reliable, we use a hybrid strategy. Online monitoring happens right on the line. Sensor act as eye, watching the mixing speed and oven heat every second. However, some things takes longer to check. So we also use offline monitoring. This is where we take samples to a lab to test moisture and shelf life. This ensures that when our cake reach the market, they are still fresh and high quality. Next is quality inspection. So we use four high-tech inspection tools, where first is X-ray system. So this X-ray system allow us to look inside the cake to find hidden defect or foreign object like stone or metal without damaging the food. Second is check weighters. So these are high-speed scale that ensure every cake is the exact weight required, which prevent undercooked or uneven product. So next is thermal sensor, where it will keep the oven strictly between 160 degree and 180 degree. And lastly is load cell. So it measure precise amount of flour, sugar, and butter for every batch. So by using this, company Z will follow the ISO 9000 series to ensure our cakes meet international quality and safety rules for export. So next is process optimization, which is the Taguchi method. This is a scientific way to find the perfect recipe for our machine and not just for our ingredients. We tested three main areas: baking temperature between 160 and 180 degree, baking time from 20 to 35 minutes, and different mixing speed. By testing this level, we found the setting that make our cakes come out exactly the same every time, even if the weather outside is different. Using these sweet spots means we have less waste, lower cost, and a high quality cake that is ready for the market. This will ensure Company Z is not only automated but also smart and efficient.
For the manufacturing costs, we begin with the cost structure breakdown. The pie chart shows the expenditure to establish the automated facility. For the machinery investment, which is the fixed cost, it totals up to 1,120,500 ringgit. The top items are laser guided AGVs, Delta robots, DGF tunnel oven, and etc. For the annual overhead labor needed to establish the automated facility, it totals up to 396,000 ringgit. For the staff, 15 employees are needed total, including the robotics technicians and QA, which are the quality assurance. And also the annual electricity totals up to 130,619 ringgit and 40 cents. It is calculated using the Sarawak Energy's peak versus off-peak industrial tariffs, which is calculated in our report. And last but not least, the unit production cost. It costs 41 ringgit and 20 cents in raw materials capital cost to produce one unit of cake. Now is the investment and revenue projection. The bar chart shows the investment and revenue. In this bar chart, total implementation cost needed is 1,747,160 ringgit and 60 cents. This includes the machinery, overhead, electricity, maintenance, and raw materials. Note that land and building are owned, therefore there is no cost. For the production targets, we aim for 400 units of cake per day as daily output, and the selling price for the cakes are 85 ringgit per unit. And last but not least, for the revenue forecast, the daily revenue targeted is 34,000 ringgit, and the annual sales revenue will be 8,976,000 ringgit. And the last part of the manufacturing cost will be the financial viability, which is the verdict of the whole automated facility established. Firstly, we look at the
pie chart, the break-even point calculated is 17.34%. This is the percentage of total production capacity of company Z must sell to cover all expenses, which includes the fixed and variable costs, and also the profit potential will be 82.66%. Any sale beyond the first 17.34% generate pure profit. For the advantage comparison, typical industry's break-even point is 50% and 60% range. However, Company Z's break-even is 17.34%. Therefore, the automated plant reaches profitability much faster than standard manual competitors. To wrap this up, Company Z underwent a strategic shift, which is from a manual small scale local producer to a fully automated high capacity facility ready for global export. This is done by two methods. Firstly, the group technology. All products which are chocolate, vanilla, and fruit cakes are consolidated into a single sponge cake family to optimize the production flow and the cellular manufacturing. The plant is organized into specific cells such as mixing, baking, finishing to maximize efficiency. And last but not least, the reliability and control of Company Z. It is adopted using the decentralized control system known as DCS. And the key benefit of this control system, if one cell, for example, packaging encounters an issue, the other cells, for example, mixing, can operate independently, preventing a total plant shutdown, which is called the fault tolerance. Our company would like to thank you for the attention and see you next time.